Okay, so what we're going to be looking at here is a problem from 2021. This is number 3. It's a solids of revolution problem, and quite honestly, this is one of the most difficult questions I've ever seen that pops up on an AP test, especially without a calculator. So let's go ahead and jump in. If you struggle with this one, I totally understand. So this says a company designs spinning toys using a family of functions y equals cx times the square root of 4 minus x squared, where c is a positive constant. The figure above shows the region in the first quadrant bounded by the x-axis and the graph of that for some c. Each spinning toy is in the shape of the solid generated when such a region is revolved around the x-axis. Both x and y are measured in inches. Now, one thing you have to realize about this c is it doesn't change where this graph crosses the x-axis. What it really does is the bigger the c is, the bigger the top is going to be as far as the shape that it's going to take on. Even so, this is a difficult question. So let's go ahead and take a look at letter A. Letter A says, find the area of the region in the first quadrant bounded by the x-axis in the graph y equals c of x for c equals 6. So it's telling us the function this time is 6x times 4 minus x squared, and we have to figure out exactly from where to make our integral to find that region. Well, it does start at 0, and the way that we figure out the other place where my integral needs to finish is I look and I say, okay, what could I put in for x that would make this entire thing be 0? There's 0 there, that's easy, but I could also put 2 in for x right there. That would also make the entire thing be 0. So I'm doing the integral from 0 to 2. So I've got my integral set up. Now the second problem I'm going to have is I need to find this antiderivative, and I need to do it by hand. We're going to use u substitution to do that. So I get du dx is equal to negative 2x. So du over negative 2x is equal to dx. So what I have here is the integral from 0 to 2 of 6x multiplied by the square root of u times du over negative 2x. The x's cancel. 6 divided by negative 2 is negative 3. So I pull a negative 3 out front. I've got the integral from 0 to 2 of the square root of u du. Now, it'll also help us to take the take these 2's and convert them into u-isms, what we used to say. So I take negative 2 and I plug that in, I get, or to take 2 and plug it in, I get 0. I take 0 and I plug it in and I get 4. And I've got the square root of u du. Now, I flip that upside down and it makes the whole thing be negative, which was the number out front was already negative. So I've got 3 times the integral from 0 to 4 of the square root of u du. Now I take the antiderivative, that's u to the 3 halves, divided by 3 halves, which is the same as multiplying by 2/3. Then there's a 3 out front already, so those cancel, and I'm going to do that, evaluate that from 0 to 4. So I get 2 times 4 to the 3 halves minus 2 times 0 to the 3 halves, and that is your answer. If you want to simplify that down, it turns out that that is 16, is what that turns out to be. So that is your answer for letter A. And that's not the hardest of all of them, but that's how we did the first one. Letter B says, okay, we have the derivative. The radius of the largest cross-section circular is 1.2 inches. In other words, whatever this is right here, that radius is going to be 1.2. So my y value at that point is equal to 1.2. The problem is I don't know where that occurs. So what I have to do is I have to say, okay, what happens when a maximum happens? Well, that's where the derivative is equal to 0. So I've got 4 minus 2, c times 4 minus 2x squared is equal to 0. So I need to solve that. Well, c is just a constant number, so I divide by that, it's going to stay the same. So I'm going to have 4 minus 2x squared is equal to 0. So I get x is equal to the square root of 2. So it just so happens at that point, x equals square root of 2 is where that occurs. Well, if that's where it occurs, then I can find out what c is by plugging in my y value, which is 1.2, times c times the square root of 2 multiplied by the square root of 4 minus the square root of 2 squared. Well, the square root of 2 squared is 2, so 4 minus 2 is 2. So what I have here is the square root of 2 times the square root of 2 multiplied by c is equal to 1.2. The square root of 2 times square root of 2 is 2, so I have 2c is equal to 1.2. So c is equal to 0.6. I don't love that, but that's how you do that one. And again, not the hardest of all the questions. Letter C says, for another spinning toy, the volume is 2 pi. So remember, I'm basically going to take this and revolve it around. It wants to know what c is going to be to make it be 2 pi. Well, that's going to be pi times the integral from 0 to 2 of my function, cx times the square root of 4 minus x squared, but I need to square that, and I'm going to try and solve for c. Well, when I square something, I square everything that's multiplying in the problem, so what I have here is that right there. I can move the c squared out in front, so what I really have is pi times c squared, because c is a constant, times the integral from 0 to 2. I'm going to multiply the x squared in, so I get 4x squared minus x to the 4th dx is equal to 2 pi. Well, I can divide the pi's out, and then do this integral, which means I have to take the antiderivative. I get 4 thirds x to the 3rd minus x to the 5th over 5, and I'm going to evaluate that from 0 to 2. When I plug 0 in, I just get 0, but when I plug 2 in, I get 4 times 2 to the 3rd divided by 3 minus 2 to the 5th divided by 5. Technically, it's kind of weird, but both of those are 32 on top, so I get 32 thirds minus 32 fifths. And all of that is multiplied by c. So what I really have is 2 is equal to c times 64 over 30, 64 over 15, excuse me, if you were to simplify that. So now I divide by 64 over 15, which is the same as multiplying by 15 over 64, and I get 30 over 64, which is what c is equal to, and you can simplify that down if you want to. You don't have to. Oh, excuse me, that's c squared, and then I have to take the square root. I apologize, I almost got rid of the c squared there. But I have to take the square root. That's your answer right there. Regardless, I honestly have to say this is probably one of the most difficult problems I've ever seen show up on any AP test. So hopefully you kind of understood that. If not, I wouldn't freak out too much about that particular problem.